analysis. So this is another technique like mesh analysis and nodal analysis. So this is analysis, okay, for analyzing the circuit. So this is the point analysis. This is S. Okay. So we're gonna do a circuit, apply superposition to find. It means we're gonna find currents or voltages in the circuit. Okay. So where do we use this superposition? When we have this multiple sources. So it is only used when you have multiple sources. Superposition is used when we have multiple sources to analyze the circuit. It means to find currents and voltages in the circuit. It doesn't work with the finding the power. Superposition is not gonna work with the finding the power. Once you find the current and the voltage, you can use them to find the power, but it's not gonna find the power directly. So what is this technique? Well, it says, here's an example, and it's a pretty easy idea, but you have to start it right. So when you have multiple sources like this circuit, you have, how many sources do we have here? How many sources do we have here? How many voltage sources do we have here? And how many current sources do we have here? So we have sources, we have, this is a voltage source, this is voltage source, and this is a current source. So we have three sources. This is the first thing when we use the superposition, okay? This is first thing that we want to know. How many sources we have? Three sources. Superposition is only applied if we have more than one source. If it's one source, it doesn't work. So three sources. Okay, one more time. The first thing you need to know when you do superposition is how many sources you have. Okay, this is one. You have to do this because what people do get into the analysis without knowing how many sources they have. This is the first thing. Now, the second thing, you need to know what you want to find. Let's say the question say find the current Ix, this current, and this resistor R3 or whatever. This is the question. So I want to find what? Ix. Okay, let's see. Now, what does the superposition say? That Ix that you want to find is, you know how many sources you have? Three. So it is three currents. Each one of them is Ix. So Ix is the sum, and this is the theory, is the sum of the currents because of one source at the time. So this is Ix because of the first source. This is Ix because of the second source. This is Ix because of the third source. So this current comes from the first source here. This is the current coming from the second source here. This is the third current coming from the third source here. This is what the superposition says. It says if you have multiple sources, we can take one source at the time, and at the end we can add their effect. Okay, so how do we take one source at a time? So we're going to take first the 30-volt source. We're going to remove these two sources. Now so I'm going to keep this. And I'm going to remove those sources. Current source, I'm going to leave it open. Voltage source, I'm going to put it close. And this is, in this case, this current here is IX because of the first source. This is the technique. So when the question says use the superposition to find something, first, how many sources? You're going to take one source at the time. Like this is the first source. Then you're going to repeat the second source and the third source. So you're going to have 3 different circuits. And every circuit, find the current you want or the voltage you want. Then add them up at the end. This is the superposition. So the idea, once again, multiple sources. You take one at a time, then you add the total. I'm gonna go and share the lecture. I hope this is not really hard. The concept, I don't think it's difficult, but we have to make sure that we actually, superposition means multiple sources. You have to know how many sources, so you can have a circuit for each source alone. This is the key. Once you have this, the rest should be okay. Okay, here's the lecture. The superposition theorem. We're gonna use it to solve multiple source networks. Okay, first, what is it? This is the theory. It's important to read this. Superposition says this: the current through whatever, resistor cross whatever, okay, is equal to, here's what it says, the sum of either currents or voltages. If I find the current, sum of the currents produced by each source alone. Okay, so we find the solution for current or voltage by using one source at the time. Okay, then once we have the solution for each source, we're gonna combine the results. We're gonna read this one more time. It's important. We're gonna find the solution for whatever we want, current or voltage. We're gonna use one source at the time, and every time we use one source, we're gonna find what we want to find. Then we're gonna add them up to get the total solution. Okay. Now, when we remove sources, remember this, we did this to find R Thevenin, Z Thevenin, and that kind of stuff. Current source is replaced with open circuit when we remove it. Voltage source is replaced with the short circuit when we remove it. Why do we remove them? Because we only want one source at the time, so the other sources have to be removed from the circuit. Here's a question. Okay. Says this is the circuit. How many sources do we have? 2 sources. This is 1, this is 1. They're saying find the current because of the first source, the voltage source, I1, sorry, and V2. So they want the current here, the voltage cross this one. When only this source is here, this is not here. Okay, so only this voltage now. So I'm gonna remove this, replaced with an open circuit. Okay, remove this, replaced with an open circuit, and then find the current and the voltage. So this circuit is removed, open circuit. The current is 120 divided by 30, 4 ampere. V2, the voltage, the current here is 4, multiplied by 10 is 40 volt. So this is the current I1 and the voltage V2 because of the first source. We remove the second source. Then we do it for the second source, the current source. When we do the current source, we remove the voltage source, we replace it with a short circuit. So now the current is gonna go this way. It's gonna be divided some here and some here, current divider. I can use the current divider, but the current is going this direction, opposite of my current. This is why I have negative. And I multiply by this resistance, divide by the sum, the current is -2. The voltage, the current here is, so if the current here is 2, the current here is 4, okay? So the voltage here is just 4 times 10, which is 40. Now the total, when we combine, we add the current because of the first source, the current because of the second source, to give me the total current. The voltage from the first source, the voltage from the second source gives me the total voltage. Now this is example to review. Here's the idea one more time. Use the principle of superposition. It means I have multiple sources. Find the current I2. So I need to find the current here. Through the resistor R2, which is this, giving that this is R, this is 4, this is 8, and this is 8. This voltage is 12. This is 36. And this is 6 ampere. So, superposition. First thing we do. I'm going to say it one more time. First thing we do, we have to know how many sources we have. How many sources do we have in this circuit?
3.
3 sources. What does that mean? I'm going to have 3 circuits. A circuit for the first source, a circuit for the second source alone, a circuit for the third source alone. So the first circuit is going to be like this. I'm going to put them small here. This is the first circuit. Only this source. I removed this and this. Now when I remove them, this is voltage source. I'm going to put the short circuit. This is a current source. I'm going to keep it open circuit. This is 4 ohm, 8 ohm, 8 ohm. The current I want to find this way, I2. The voltage here is 12. Okay, volt. So this is the first circuit. This is only source 1. Now the second circuit, I'm going to use only source 2, which is this one. It doesn't matter the order now. So I'm going to do this. This source is removed. This source is removed. This is staying. Now this source was a voltage source, so we replaced it with a short circuit. This is 6 ampere. 12 ohm, 12 ohm, 4 ohm. The current I2 is going this way. Okay, 1 second, guys. Okay, sorry for that. I just get someone coming in to tell me something. Okay, so first circuit is the first source, second circuit is the second source, then I need a third one. A third one is this source, the 36, so we have this. Oops. So this source is open, and I have this one here. Now the voltage source is replaced with a short circuit. Current source is open circuit. This is 36, and this is the current I2. See, this is the current I want. The question says find I2. This is 8 ohm, this is 8 ohm, and this is 4 ohm. Now, I2, 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 that is these three currents, they're not actually I2. The sum of them is I2. So this is why I'm going to give them different name. So I'm going to say this is I2 because of the first source, I2 because of the second source, and this is I2 because of the third source. And at the end, I2 is actually the sum of those three values. So I2 because of the first source, I2 because of the second source, I3 because of, also I2 because of the third source. And this makes sense. If you have multiple sources, every source will contribute by something, and at the end, the total is the sum of individual contribution. This is like every source is giving some current or voltage, and at the end, the total is going to be the sum of those voltages and currents. This is exactly if the three people are contributing to one thing. One is giving 5, one is giving 3, one is giving 7. So the total is the sum. And sometimes one is giving 10, one is giving 20, and one is taking 25. So it's negative value. That is still contribution, even if it's a negative contribution. Is this okay so far? Is this okay? Like defining the three circuits for the three different sources, that is the key. And that is basically the answer of the half of the question. So make sure that in an assessment, you draw the three circuits. Even if you're not able to analyze each circuit, then it's okay, but as long as you draw them. Voltage source, when you remove it, put a short circuit. Current source, when you remove it, open circuit. And one source at a time, only one source at a time. You keep one source. Any questions? Any questions? Okay, now because this is an example, we're gonna actually continue with the example. By the way, we finished the lesson. The lesson, this is basically what is the lesson. It's just the concept. Then everything is has exercises and analysis of different circuits. So this is the first circuit, which is basically just this one. Look at this source. It's gonna give me current in this direction, right? This direction. And it's in the same direction as I2. Now this branch is open, so we can cancel it. The current in this circuit is just the voltage divided by the total resistance. So I got this current 1. The total voltage divided by the total resistance, E1 divided by these two. So this is the first part. This is this one here, this circuit. This is now only applying the source E1. Now we're going to go to the second one. This is the second circuit when you only apply the voltage E2. I'm going to erase this. So now we only apply E2. So we remove the current source, open circuit, the voltage source, short circuit. Now this voltage is going to give me current this way. This is an open branch. Remove it. Current is the voltage divided by the resistance, gives me 3 ampere. So the first one was 1. The second one was a 3. Okay, so the first source give me 1 ampere. The second source give me 3 ampere. Now we want to know the third source, which is the current source only. So those two are removed, short circuit, because they're voltage sources. Current is going this way. Some will go here. Some will go here. So this source is going to give me current opposite of my current. This is why it's negative. And this current here, which is 6, some of it will be divided, some of it will go through R1, some will go through R2. So it's going to be divided between R1 and R2. I can use the current divider. Okay. Once you use the current divider, you're going to get the answer, and the answer is negative because the source is going to give me current opposite of the current that I want to find. So at the end, the third current is negative. As I said, the contribution can be positive, can be negative, no problem. So when you add them all, you're going to get 2 ampere, and this is the answer for this question. So 3 sources, 3 different circuits. For each circuit, you're going to find I2. At the end, you're going to add them up, and that is the I2 current in the network. Here's another example in the AC. Use the superposition. Okay, since I want to use the superposition, it means I have more than one source. Okay, I have more than one source. Perfect. What should I do? One source at the time. Okay, so first, I'm going to take this source and remove this. So the circuit will look like this. J8, 6, and J6. This is minus J8. So what we want the current here. So open a branch. This is a branch. You can remove it. Oops. You open a branch here. It's not going to affect your circuit. This is for the current source. When we remove it, we leave an open circuit. So this is not going to affect. So this is the first circuit with the first source. Now the second circuit, we're going to remove the voltage source, replaced with a short circuit. Everything else is the same. And the current source. This current source is going to give me current this way. It will be divided some here and some here. I can use the current divider, but I have to assume that these two is one impedance. And this impedance is just the sum of them, 6 minus J8. So this is the second impedance. So two sources, sorry. I'm going to analyze them by the superposition. So I'm going to take one source at a time. So first, I'm going to take the first source. Oh, here I did them in another way. So this is the voltage source. Okay. Voltage divided by the total impedance. This was J6. This is a combination of J6. And I had here 6 and minus J8. You add them up, voltage divided by the total impedance gives you the current. This is the first current because of the first source. Now this is the second using the current source. Voltage source is shorted, so there is current going this way and current going this way in the same direction as the current I want to find. So this current is going to be divided by here and here. Current divider, it says if you want the current in Z2, multiply by Z1 and divide by the sum. And this is what we did. This is J6. This is 6 minus J8. So we multiply by J6, we divide by the sum. And the total current here is given 2 angle 0. So you can find this current. So two currents, one because of the first source and one because of the second source. I want to find the total current in the circuit. I just add these two currents and you get the answer. One more time, the superposition technique. The superposition technique says that to find current or voltage, you can find the current or the voltage you want to find by applying one source at a time, one source at a time, okay, one source at a time, then combine the individual results, each source result, combine them, add them up at the end. So if you have 10 sources, you're gonna have 10 different circuits, one source at a time. If you have 5 sources in the circuit, you're gonna have 5 different circuits. Each circuit will have one source only. Here is a question and I want you to try. Please try it while I'm actually going to take the attendance. I think we have 4 exercises. Yes. So this is first one. We can do 2 and we leave 2 till the next class later. Superposition technique is not difficult as itself, but you have to start it right. You have to, when you start it, you have to start it with the idea that I'm going to take one source at the time and I'm going to find the thing that I want to find from one source at a time. Let me take the attendance. Do it, please. Do it. Assignment 5, by the way, will be open today. Assignment 5. Don't do like assignment 4. You leave it the last minute and then you're not getting the mark you want to get. Do it early. You have the weekend. Try to do it tonight, tomorrow. So if you have questions, you can ask me. So what is today? The 10th. Okay, Abdullah Khalid. Muhammad Mohsen. Hassan. Hassan. Am I doing the wrong class? Rand. Thank you. Yazan.
Yes.
Thank you. Sarah. Thank you. Abdullah Ali. Maryam Ahmed.
Here, Mr.
Thank you. Abdullah Ahmed. Ahmed Tayyib. Asma.
Yes.
Thank you. Muhammad Yusuf.
Yes.
Thank you. Lean. Thank you. Fahad. Amal. Abdullah Hassan. Hazim. Samar.
Here, sir.
Ziyad. Watif. Isam.
Yes, sir.
Thank you. Manal. Thank you. Hamad.
Here.
Thank you. Asia. Thank you. Sharif. And Ahmed Ayman. Okay, so we'll go back to the lecture and try to do 2 exercises if we can. 1 maybe is enough. Maybe we do 1 set. So we do have 3 left for the later today. Okay, so the concept of the superposition is applied only when we have multiple sources. Here we have 2 sources. So we're going to have 2 circs and what we want to find. So this is one source. Maybe even, let me just do it in the middle. And this is the second source. At the end, I'm going to find I2. This is what I want to find. I'm going to find I2 because of the first source, plus I2 because of the second source, and put them here. So here, I need to find I2 because of the first source. Then here, I2 because of the second source. Okay, so this is why I want to get here. And this is why I want to get here. And finally, I want to find I2 because of these 2 here. You have to know that this is what you need to do. Okay, they say find the current I2, find the current I2 in that direction using superposition. So first, I'm gonna only apply only the source E, then only the source I. Two sources, 2 circuits. 2 sources, 2 circuits. Superposition. So when I apply the source E, this is the circuit. Now this is the original circuit, okay? 6 ampere, 6 ohm, sorry, 12 ohm, and 36 volt. This is where the current you want here. I'm gonna draw the circuit again. 9 ampere, 36, 12, 6. So this is the current I want to find. I2, because of the first source. Here I2, it's the same current, but because of the second source, it's going to be I double prime. Now I need to remove now this is just the two circuits. I need to remove the sources. So now I'm going to be only using E, so this is going to go. And this is now it's going to, oops. I touch it here. So here's the changes I made. Here I removed the voltage source, I put short circuit. Here I removed the current source, I replaced it with the open circuit. So these are the two circuits here. The first circuit only E, and the current source is removed with an open circuit. The second circuit is only the current source, and the voltage source is removed with the replacement. The replacement is a short circuit. I'm going to actually try to make the circuits look nicer. This circuit open branch, you can remove it, so this is what you have. This is the current I2 prime because of the first 12 ohm, 6 ohm, 36 volt. So here it's an easy circuit to analyze. One source, one loop, so I2 prime equals to the voltage 36 divided by the total resistance, which is 12 plus 6. This gives me 2 ampere. So I'm gonna put the answer here, 2 ampere. I come to the second circuit. I'm gonna make it look nicer. 9 ampere resistor here, and another resistor here. This is just 12. I can put it here in one branch. So this is 12 ohm. This is 6 ohm, and I want the current here. I2 double prime. Double prime because it's just to mention it's the second source. So I can use ohms, not ohms, the current divider. I2 double prime. This current D9 is going to be divided between these two resistors. So I multiply by the other resistance. I want it in the 6, so I multiply by the 12. And I divide by 6 plus 12. And I multiply by the total current, which is 9. This will give me 6 ampere. So this is 6 ampere. Last thing, this is 2 plus 6. So it is 8 ampere. This is the answer for this question. Is the procedure okay? Now, as I said, lesson 11 and 12, they're not difficult. They're not difficult, okay? Unless the network is very difficult, but the concept is basically easy and it makes sense. The sources, each source will give me some contribution. I can find the individual contribution and add them up to find the total. Now the total means the original network when all sources are connected. Any questions? Any questions? No? Okay, I'm gonna give you an idea about the next question and hopefully you can do it in your own. So we have, as I said, we have 3 left. This is one of them. And I think this is similar to assignment 5. No, assignment 6. This will be assignment 6. Okay, this one has 3 sources. This is one source. This is another source. This is another source. So you're going to have 3 different circuits. Then at the end, you're going to combine what you want, which is I1. Now, sometimes the source will give you a current in the same direction. Sometimes the source gives you the current in the opposite direction. So if it gives you current in the opposite direction, you know you have to put the negative. Then this is AC, 3 sources as well, 3 sources here. So you're going to try to find IL from the first source, the second source, and the third source. The last one is 2 sources, and you're going to try to find this current here. Not difficult. When you take one source at a time. The circuit is complicated when you have so many sources together. And I will see you inshallah. Those are the answers anyway. This is exercise 1. This is exercise 1. We did 8 ampere. We have 3 exercises, then we finish this lecture. Important thing is the first part here, what it means. And I'll see you inshallah later, 3:30. Try to do the exercises on your own, please. And assalamu alaikum. If you have no questions, then we're good.